everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. In the previous video, we ran a linear interaction model in R. We saw the dummy continuous and continuous case. Now let's do the same for log models, where the effects that we're computing are percentage effects and elasticities. We're going to use the same dataset wage2 that we have used in the previous video. But in order to move into the log case, we have to log the wage variable using R's built-in log function, which is going to give us ln wage, which is right here. The model that we are looking into now is model ln wage being equal to beta 0 plus beta 1 education, merit, education, and merit. So keep in mind the interpretation now is going to be percentage effect of education varies with marital status. Building the model is going to be the same, so interaction term introduced with the column and always using the constituent terms in here. We're going to see a summary of this model very quickly. So we see that education is highly statistically significant in here. Unfortunately, merit and education doesn't look like they are statistically significant. But keep in mind that the actual interpretation in here, the syntax being the same, the interpretation will have to change because the dependent variable is a log wage. So now is the coefficient on education is the percentage effect, not a unit effect. And you can look in here, for instance, just with education. If education increases by 1 year, then we can say that that is associated with an increase in wages with approximately 6%. So we'd have to multiply the 0.05 to 9 with 100. Keep in mind, this education is for the unmarried subsample. So the interpretation would also have to be like this is the associated percentage change for the unmarried one. But keep in mind, it's no longer a unit effect. We've always done in our videos the marginal effect, the delta y over delta x or delta z. So if we're looking now at the marginal effect of education, which means like we're doing delta ln wage to delta education, we are going to need the beta 1 and the beta 3 as part of that, because education by itself, that is for the unmarried, and then the education merit is going to give us the difference, the additional that it's needed for the married subsample. So we're going to save these numbers based on the regression that was just run in here. And because, again, we're looking at a percentage effect, we need to multiply by 100. So what we're going to do here for the predictions, we're going to have to multiply those effects with 100 in here. And let's see to these returns for the 3 different cases as we did in the previous video. These are, again, the same numbers that we have seen here in this regression, but now in percentages. So for return to education for the unmarried, that's a 529 that we saw here. For the married, it should be the 529 plus the beta 3 in here. That's why we see the 628, and the actual difference between the two is the 0.99%, which is what we would get if we multiplied the beta 3 in here by 100. So it all fits within that theoretical framework that we have seen so far, okay? So again, the interaction term tells us how much the percentage return differs between married and unmarried individuals in here. Let's plot the log level now interaction just so that we can also have a visual overview of this particular case as well. The code is pretty much the same as in the previous video, so we're creating predictions for the married and for the unmarried group, and ultimately plotting them. So this is the new fitted lines that we see in here. So keep in mind, now we've got predicted log wage in here. And again, it seems that the lines are not really parallel, which would indicate that the interaction is present. So it means like there would be a difference into how education is affecting log wages due to marital status. Okay? Let's go one step further and see how exactly this visualization would change the moment that we have a continuous interaction, which means that we will have to plug in again values for experience now. The code being the same, I will go ahead and run it, and keep in mind in here, again, we're going to use values of experience 0, 5, 10, 15, and 20 in order to see like the actual results of like how experience is affecting basically the elasticity. So experience 0, we've got here 0.8, and then for 5 is 0.93, for 10 is 1.063. Because keep in mind, when we say that we have a 1% increase in education, now the derivative should have been beta 1 plus beta 3 z%, okay? That's why we're going to see a different elasticity result for the different levels of experience. Let's plot the different lines in here, just as in the previous one. So again, we see different lines as we would have expected, because every different value of experience is giving us different predictions for the log weight. Okay. What you might want to always keep in mind is that each of these lines is simply representing a different elasticity based on that value that you are plugging in. So if we wanted to do a quick comparison summary by bringing everything together, so both the dummy times continuous and continuous times continuous, we can look at that in here directly. So we've got model 1 and model 2. Of course, model 3 was the log-log case. So these were also the results that we had from the previous video. So the effect of education for the unmarried, which was 42, and for the married, 64. In the case of the log level, we had for unmarried 529 and for the married 628, which we clearly expected to be different because now we had a log level model. And then again, for the log-log model, it changed because now we have full elasticity. So even the interpretation now would have been different by saying that we are increasing education by 1%. So the percentage change in wage would have been a certain level depending on the experience that we plugged in. Okay, so these are all three different models, three different interpretations. The only thing that never changes is the underlying structure all throughout of this. Okay. The other thing that you might want to keep in mind is that log interaction models basically are following the same syntax as the linear ones. The only difference is that now you have to be the one that is aware which of the models you're using in order to do the interpretation of the effects. This completes our series for the interaction models. You can find the code in our website if you want to play around with it and see the different kind of graphs that you can create depending on the variables that you choose. In the next videos, we'll do the same thing in Stata, but by introducing how Stata does all of these differently. So stay tuned, and I'll see you in the next video.